Imagine a tech solution that lets you build a performant web app, hook it to a reliable REST API, back that API with a scalable database solution, and then deploy all this to the edge with just a couple of clicks. Sounds too good to be true? Well, it's not. Deno, the TypeScript-based JavaScript runtime, enables all the above for you. They just announced the release of the final piece of the puzzle, Deno KV, a global database for global apps. The selling point looks more than appealing. KV allows you to read data in milliseconds worldwide with a promise of consistency and ACID transactions. So let's not waste any more time and look at KV in action. Believe me, after this video it will become clear to you that this one can become a real game changer in the industry. We are able to develop and test KV locally using Deno CLI, so make sure you have that installed on your local environment. Then let's simply create a TypeScript file and we are ready to go. As a quick FYI, Deno is, at its core, a JavaScript runtime environment built as an alternative to the more popular Node.js. Both Node and Deno were created by Ryan Dahl, who was able to leverage all the lessons learned from the past decade of Node development and create a runtime better suited for the modern web space. So, besides the better overall performance, Deno comes packed with quite a few goodies, such as built-in support for TypeScript and a security-first approach with a fine-grained permission system and safer NPM packages. When developing Deno projects, you'll most likely use Deno Deploy to publish your apps and bring them in front of customers. Deno Deploy not only abstracts away all the deployment implementation details, but also leverages a large cloud network to push your code to the edge. This will help you decrease the latency and have better performance gains. Deno has a bunch of other powerful features, like a better way to download and manage dependencies, and I have a few detailed videos on this channel if you are interested in a more in-depth look at the whole Deno space. Right now, however, we'll get back to the code, where I created a basic REST API using the Oak middleware. There is nothing too fancy about this code, and this will simply act as an interface we can call to trigger various actions in Deno KV. I defined the basic create, read, update, and delete operations you should be familiar with. Of course, in a real project, this endpoint should be restricted for unauthenticated access, and you will probably end up adding various validations, since the user-generated data should not be trusted. Next, we'll create a member service file, which will contain all the business logic related to us working with the KV instance. Deno KV is available since version 1.32, and, in short, it is a built-in key value store that persists data on the disk, allowing for data storage and access across services and system restarts. It was built to work with JavaScript and TypeScript, so we'll be able to store any type of JavaScript value in there without worrying about serialization. We can easily open a database connection via the Deno Open KV function. The function accepts an optional parameter pointing to a database path on the disk. In our case, we are not going to specify any path, so the data will be persisted in a global directory bound to the script used to open the database. If you worked with databases in the past, I'm sure you'll find the lack of configuration needed to work with KV refreshing. I'm coming from a Java background, and in such environments, you have to jump through quite some hoops to safely get a database connection. Okay, so Deno KV entries have three different parts: a key, a value, and a version stamp. Let's look at all these in detail. Keys are a sequence of key pairs which can be, among others, strings, numbers, or booleans. Using a sequence of parts is an interesting design decision. On one hand, it allows developers to create flexible structures and better organize the data. On the other hand, it eliminates the possibility of delimiter injection attacks, since there is no visible delimiter. So, in our case, we can store the member details for a specific entity at the following key sequence. This will save the data under the member's path and will associate the following generated ID to our entity. If you want to independently store this member's address at a different key, you could use a key sequence such as this one. Values are arbitrary JavaScript primitives, objects, or arrays. You have full flexibility here, and, as I said, you don't really need to worry about serialization or deserialization of the stored data. Finally, version stamp represents the current version of a value for a given key. This allows the system to manage concurrent access to shared resources without using locks. When a read operation occurs, the system returns a version stamp for the associated key in addition to the value. This discussion can get rather technical, but for the purpose of this video, it is enough for you to know that the version steps are employed by KV to provide an optimistic concurrency control for transactions. Don't worry, this is not as complicated as it sounds. Basically, optimistic concurrency control is a fancy way of simply saying that multiple users can access and modify the same data at the same time without blocking each other as long as there is no conflict between these operations. In more traditional storage solutions such as Postgres or MySQL, row locking or other blocking strategies are used to ensure data consistency and improved concurrency. I should however clarify that, in the context of a key-value store like Deno KV, transactions are a sequence of operations executed as a single atomic unit of work to ensure atomicity, consistency, isolation and durability, or in short, ACID. Okay, back to the code. Once you have your data into the Deno KV, you can easily read it either via get function if you know the exact key, or a list function if you only know the key prefix or the key range. Database reads and all other operations are extremely fast since Deno KV is built on top of FoundationDB. This is a distributed database designed to handle large volumes of structured data across clusters of commodity servers. FoundationDB is battle tested in production for quite some time now, with services such as iCloud or Snowflake heavily relying on it. As opposed to the regular SQL, KV doesn't provide any type of operator to update the value at a specific key, so you'll need to employ the same set function for such instances. On the other hand, you can use delete operations to remove an entity from the store. Okay, so we still have to look at some transaction examples and discuss secondary indexes, but first I would like to take a second and ask you to consider helping me fight the YouTube algorithm by liking this video and subscribing to the channel. To work with transactions, we'll use the atomic function. Then, inside the workflow, we can check that the entity keys stay the same and then update the active entities. The transaction is then concluded by calling the commit method. The idea here is that if one of the check or the update method fails, the entire batch of operations will fail as well. Until now, we used the get and list functions, which target the key for querying purposes. However, there are a lot of instances when you'll need to query the actual entry value for various purposes. A very straightforward example is to fetch a member by its email when the entity key consists of just the member ID. A common pattern to address this scenario is to create a secondary index which stores the same value under additional keys that include part of the value. However, this flexibility comes at a cost, since maintaining the consistency between the primary and the secondary keys is crucial. This is why it is always a good practice to use atomic operations when inserting, updating, or deleting data. This approach ensures that the group of mutation actions is executed as a single unit, and all actions either succeed or fail, preventing inconsistencies. So, I updated my upsert member method and added a secondary by email key. Then, using the atomic function, I am doing the checks and sets I already described earlier. Finally, I can simply define a getByEmail service method to retrieve the data. Simple enough, right? Combine all the KV power with the rest of the Deno platform offering, and it should be clear to everybody that Deno is a real competitor to the likes of Vercel or Firebase at this point. Their offering is pretty much the same, but Deno's JavaScript runtime offers a level of flexibility not matched by the competitors. Remember though that Deno KV is still in beta, but I think that we can all agree that this feature looks very promising. Let me know in the comments what are your predictions about the Deno ecosystem moving forward, and until next time, thank you for watching.